Fixed deferred annuities, and we have a formula for it, but we often just call it annuities. So I want to talk to you some about this. We use annuities to anytime that we are making a regular fixed deposit over time. Regular means the same day basically every month, and fixed means it's $50 every month. We're not switching to 50 one month, 100 to the next, 250 to the next, back to 50. It's going to be 50, 50, 50, 50. Okay, so that's our fixed part of it. So anytime that you're making the same size payment every single month or every single year, you can find out how much you're going to have with your interest compounded monthly or annually, however often you deposit, and what you'll have over time in your account. And that's what this formula is good for. So let's take a look at the formula. It says F, which stands for the future value, so the amount of money you're going to have at the end of your investment period, equals L, and L down here is the future value of your last payment, and we have two options. One of them is just the payment amount, and that would be when you don't gain interest on your last payment. So say you put your payment in on the first of the month, and on the first of the month you make your last payment, and then you go in right away and you take the whole amount of money off. The first payment was sitting there a day or two, and so the bank won't give you interest on that, and that's the time when you would use this P. Just put in the P because it's not gaining any interest. Now if you have the case where you put the money in on the first of the month and you come in on at the end of the month after it's been sitting in the account for a month, then you would gain interest on your last payment. And so if that's the case where you put the money in at the beginning of the month and take it out at the very end, then you would use this formula for the L. It is the payment times the last month's interest. So that's the only difference. We either multiply in that last month's interest or we don't. Okay, so we've got those parts. Now this up here, 1 plus little p. Little p is our periodic rate, and we saw that a little bit on the compound interest problem, but it's the rate over the number of compoundings. And so if you're compounding annually, remember your n is going to be 1 because it happens one time a year. And if you compound monthly, then your n is going to be 12 because there are 12 months in a year. There are 12 times where you'll compound this money. So that's where your n's come from. Now the R, remember, is the interest rate for your account, like the 7.5% that they're talking about for this first problem. That'll be your R, but you have to convert it to a decimal. We use them in decimal forms in this formula. T is the number of payments that you're going to make, this capital T, and then we see it up here. So capital T is the same thing that we were using in the last problem with the compound interest as n times T. So it's just how many payments you're going to make. Now I want you to be careful on the annuities because sometimes we tell you his 40th and last payment, his 40th and last deposit generates no interest. We're telling you that's the capital T right there. You don't even have to multiply the n times the T. We already did it for you. Now occasionally we'll tell you it was this many years compounded monthly, and so you'll have to multiply the number of years times the number of months, and that's this NT. The N is the number of compoundings, which would be 12 for monthly, and then the T would be the number of years that you had. So that's where that comes in. I'll show you some examples. Hopefully that'll be more clear. We take the 1 plus little p, raise it to the t power, and then subtract 1. And then after we do that, we're going to divide the whole thing by that little p, which is that r over n again. So what we want to do is calculate the big T and calculate the little p. Then fill in our formula. And then use those in their decimal forms in the formula. And I'll show you how to do that. Alright, so we're talking about Marcus in this problem. Starting at the age of 25, he invests $2,000 at the end of each year in an IRA which is an individual retirement account. It's money you put away every month or year, in this case every year, to save for your retirement. And you don't get taxed on the income that you make on that, the interest you earn, until you retire and start taking the money out. So presumably you'll have a lower interest rate at that time, so it's kind of a tax sheltered account, and it's perfectly legal. Okay, so you have an APR of 7.5% compounded annually. How much money will be in his retirement account when he retires at the age of 65? Now I could just take 65 minus 25, and I would get 40, which would tell me 40 years. And then I see that they've already told me his 40th and last payment, his last deposit. So then I also know, since he's putting the money in at the end of the year, if he takes it out, he's probably not going to get the last month's interest or the last year's interest. So, and they're saying that here too. It's not going to gain any interest on that last deposit. Okay, that's important for us to notice, because this part where it says generates no interest, his last deposit generates no interest, that tells me that my L is just going to be P, the big P. I don't need to do the interest on the final deposit. So let's see, what do we know? I want to know what the future value is, and I think it looks like that's something I don't know and I need to find. And my capital T, that's going to be the number of payments that he'll make, and we said right here he's making 40 payments. I can also do capital T is little n times T. My little n we said was 1 for the annually, so that'll be 1, and then T was the number of years, which is 40. And so that does come to 40, just like they said, the 40th and last deposit. So a lot of times part of the work's done if you can interpret it correctly. So my capital T is going to be 40. The next thing I have in my list is the little p. So let's see if we can figure out little p. And little p, remember, is R over N, and my rate was 0.075. We start with the percent and divide by 100. And to do that, you can just move your decimal 2 places to the left, or you can type it in on your calculator, and I would put 7.5 divided by 100 and get 0.075. So that's my rate. I also need to put it over N, and remember N was annually, so compounded annually, so 1 time a year. So it's just going to be 0.075 for my little p. And that's easy enough. I can write that into my formula. And I had my L, I figured out, was my P, which is the amount of money that I'm depositing, or my payment amount every year in his case, so it's the $2,000. So I think I'm ready to fill in my formula. I have F equals, that's the part I don't know, my big P is 2,000 times this big square bracket, and then I have 1 plus my little p is 0.075 raised to the capital T, and that was 40, then minus 1, and then divide by my little p, one more time for the little p, 0.075. And there's my whole formula. I'm going to show you the whole thing worked on the calculator, because you want to put it in the calculator and keep it there as you're working so that you don't lose any precision. So I'll show you on this problem. First thing I want to do is work inside my parentheses, the big ones. And let's see if I can show you a little bit about the order of operations on this problem. So first I work inside the big parentheses, then when I'm inside there I see another set, so this is going to have to come even sooner. Calculate that, and then so this will be the very first thing, and then the second will be to take it to the 40th power, and then the third will be to subtract the 1, and then the fourth thing will be to divide by the 0.075. So I'll take care of everything in the numerator and then divide by the denominator, and then the very last thing is going to be this implied multiply here. That'll be my 5th step right there. Okay, so let's give it a try. We have the 0.075 sitting on the calculator, so we may as well add 1 at this point. That gives us the 1.075. And normally I won't write out every step, but when you're first learning it, I will, so that you can look back and see if you're getting what I got at each step of the way. So 1.075, and I'll still have to raise it to the 40th, subtract 1, and divide by 0.075. Okay, next thing I need to do, it says second, we decided that was next, so take it to the 40th power. So I need to use my to the button right there. So to the 40th power, and push equals, and I get a nice big number there. So now I have 18.044 ... minus 1. That means I'm being lazy and not writing out all the decimals. 0.075 times the 2,000. Okay, so I'm doing great. My next step is to take care still, it says third, I have to subtract the 1, so this big number 18.044 and on, subtract 1 from it. So subtract over here minus 1 equals, and I get 17.044, that shouldn't surprise me at all, divided by 0.075. Last thing inside the parentheses is to divide by the 0.075, so I'm going to do just that, divided by 0.075 equals, and now I'm down to 2,000 times 227.256, and it goes on. And then the fifth thing, the last thing, is to do the multiply with the 2,000, and I really technically should have an equals F out here on all of these, because I haven't changed that. I'm just being a little bit lazy. So then I'll multiply, so times 2,000 equals, and you can see my solution now. I have F equals 454513 point, and I want to change it to pennies, so I want to round to the 3 cents right there, but the next digit is a 9, so I'm going to have to bump it up to 4 cents. So I can say 454,513.04 is the value in Marcus's account. In 40 years. And now remember, he is depositing some money every year, and he's getting interest compounded every year and added back into the account, and that's why the money is so good, why he gets so much in there. Okay, so he'll have $454,000, so $454,513.04 in his account. Let's look at another one so that we can start to see the patterns there. So the first time it's just a little bit awkward, and now it should look a little bit better. So here we have Amy. She's starting at age 30. She invests $250 at the beginning of each month. When it says at the beginning of the month, I start to suspect that she's going to have interest on her last deposit. So let's see if that's the case. She's using an IRA as well. Her interest rate is 2.25% compounded monthly. How much money will there be in Amy's retirement account when she retires at the age of 65? And now look at this. Assume that her 420th and last deposit generates interest for 1 month. So it does say generates interest, which I suspected because she's putting her money in at the beginning of the month. So this one we'll have to use the expanded form of the formula. Now let's see if we can write out all those values that we've figured out. So her principal, or starting her present value, her monthly payment will be $250. Her little rate is 0.0225. Remember, you can do 2.25 divided by 100 if you're not sure about those decimals yet, and 0.0225 for her rate. Compounded monthly, that is telling me that the N is 12 because there are 12 months in a year. So every month, every 12 times a year, she'll have her interest compounded. And how much money will there be in her retirement account when she retires at the age of 65? I could take 65 minus 30, and I would get 35, and then multiply it by 12, and I should get 420. Let's try it. 35 times 12. Yep, 420. So that's where the 420 came from. But the bottom line is that she's going to have 420 payments or deposits into this account. And that we did need to know for our capital T. So our formula says F equals L times the quantity 1 plus little p raised to the capital T minus 1 all over the little p, close the big parentheses. Remember our L, we were going to have to assume her last deposit generates interest for 1 month. That means her L is going to have to be P times the quantity 1 plus little p. So we may as well put that in now. Let's see if I can slide that over or not. Nope. Maybe this way. It's not going to select it very well. Okay. Let's just rewrite that portion. So I'll have, instead of the L, I'm going to put my big P, 1 plus little p, times the big parentheses, 1 plus little p again, raised to the capital T, that quantity minus 1 over the little p. So there's my annuities formula, given that I have interest in the for the final payment. So I don't know my F again. My big P was the $250. 1 plus, I didn't calculate my little p yet, I should do that. That's R over N, so it's going to be 0.0225 over N was 12. So let's calculate that. And I get 0.001875. So I'm going to have to put that in a couple of places. You can see right here, and right here. So I can write those in, 0.001875. It just takes up a lot of space. 1 plus 0.001875 to the capital T, which was 420, minus 1, missing a parenthesis here, 0.001875, and the close parentheses. Now what I want to do is show you store for this, because it'll help so we don't mess up when we keep typing in that P. So I'm going to store on this calculator. I can store in letters A through D or E. So I'm going to store, and you should have a little button that says STO or something along those lines. So I'm going to store, I don't think that, yeah, that was my number. Store that, and it's giving me choices A, B, C, D, E, and so I want to store it in A, so I just push enter, and then it's telling me, hey, I stored that in A for you, and there's the value that it is. That's perfect. So now when I need to use it, I just have to pull it out of the A bin, and I'll get that 0.001875. So I wrote that on there also to help me out. But what I need to do here is add 1 to that. I have to still work inside the parentheses first, so plus 1 equals, and now I have 1.00875. And I still need to raise it to the 420th, subtract 1, divide by, I'm just going to show it as what's in A, that I have to divide by. And then one other little trick that I'm going to use, and that is, instead of using A for this and having to add the 1 to it already, I already did that right here. I added that 1. So I'm just going to store that in B. And then instead of pulling it from A, I'll pull from B, and I won't have to do that whole calculation. So store again, and this time move over 1 so it goes into B, push enter, and now it tells me I stored the adding 1 part in your B variable. So then that whole thing in that parentheses there, that's that 1 plus the 0.001875 is stored in B, and then I have to multiply by 2,000. So that's the extent of my tricks because it makes things a little bit easier. So what I want to do now is take this 0.00875 that I added the 1 to, raise it to the 420th. So I should be able to just do to the, on my calculator, to the 420 equals, and I get 2 point, let's see if I can write this down, 2.196, and then it goes on and on. I still need to subtract 1, divide by what's in A, multiply by what's in B, and multiply by 2,000. So that's where I am so far. Subtract off the 1, so minus 1, and now I have 1.1962 on and on, divide by the A, that'll come next, and then multiply by B, and then multiply by 2,000. Okay, and I might combine steps a little bit, so I'm hoping you can follow along. First thing, divide by A, and so I have to do recall, which is right above the store on this calculator. So it's RCL, so second store, that gives me the recall. I want to just divide by the A, not the B, so I'll just do enter. And that has it written on the problem. Now I just push enter again and it'll give me the answer to it. So I got 638.01, and then it's 3, so I'm just going to say dot dot dot. Still have to multiply by B and multiply by 2,000. Remember, these are all equals F, so just put the equals at least so we can see that. And I'll go ahead and try to write all these out for you. So we have that 638.01 sitting on the calculator. So times, and I'm going to have to recall again. So second store, move over to the B, and that gives me the 1.001875. So enter. Enter again so we get the actual calculation. And now I've done B times the 638 number, so I'm left just now with 2,000 times the 639.2, and it goes on. So do that last multiply, 2,000 equals, and I get my F equals, and it's money, so I'll put a $sign at the start. Whoa, it's a lot of digits. 1,278,418, and I would put 97. I'm checking the next digit. It's a 4, so I'm good with 97. So Amy will have $1,278,418.97 in 35 years. So that's a pretty nice deal for Amy.